So here we are in the second year physics teaching lab. My name's Lincoln Turner and I'm here with Kelly, who's studying second year physics, and Tim and Dan, who are also second year physics students. And today we're looking at the optics of beetles, which are not a normal optical element. So, but before we talk about the prac, I'd like to ask you, Kelly, why did you decide to do physics at second year?
Well, I found it really interesting. I think that was one of the reasons, and also because it's got maths in it and I like maths. So.
Great. And why did you decide to do physics, Tim?
Physics is a prerequisite for my course. So I'm doing engineering science and I need to do a physics and maths major, or two maths majors, and I didn't want to do that.
Okay, so one who wants to do maths and one who wants to avoid. Dan?
Yeah, much like Tim, I'm doing science engineering, and physics is so much more interesting than, well, it's got a lot more conceptual ideas than maths, so it's really cool. That's pretty much why.
So a lot of students at second year are doing both a physics degree and an engineering degree, a double degree at Monash. And I wanted to ask you guys, do you find that the physics helps the engineering, or does it repeat stuff that's in the engineering? How do they interact?
In first year there was a lot of overlap, and especially when we're doing dynamics and things like that, Newtonian physics, but now it's more, one's like macroscopic scale and this is more quantum and light waves and things like that, so it's different material.
So it's starting to be quite separate at second year.
Very much so.
So today we're looking in this prac at the optics of a beetle. It lives in the jungle in Papua New Guinea, and also it lives here in the second year lab, and you can see we've made it a jungle home. But there's something interesting about this rather dead beetle from an optics perspective, and it's been Kelly's job to work out today in the lab what's going on with the optics of this beetle. So what have you found out, Kelly?
Well, we've been looking at how the different light is polarized with our linear, our Polaroids and our quarter wave plates, and we discovered that the beetle has circularly polarized light coming out from it, which is quite interesting because very few things have that. So then we were, considering why that would be, because as humans we can't distinguish between circularly and non-circularly polarized light, but we thought maybe the other beetles could tell, and maybe they could see the other beetles better, but the predators couldn't.
So that's a very interesting hypothesis, and actually we wouldn't usually tell you this till the end of the lab after you've worked it all out, but in the last few years only, people have actually done some studies on live beetles that can still around to see other beetles, and they've worked out that indeed, just as you speculate, the beetles do have polarized vision. They can actually see the world in shades of polarization as well as color, and as you suppose, the hypothesis is that beetles need to see other beetles, but they don't want to be seen by predators. And so being green helps you hide from predators that don't have circularly polarized vision, and being circularly polarized might make you stand out if your eyes work that way. And our eyes don't. But what you've been able to do here in the prac today is use optical elements to reveal that circular polarization. So I'd say you'd really worked it out, both the physics of what's going on and the biology. Great.